said, Dale, what does the sustaining engineering department do? Dale would have said to me, they do change requests for our cross-IT applications. And if I'd said to him, Dale, do you realise that mostly they do something called PTCs that no one can actually tell us what they are, and the rest of the time they do estimates? And when they're not doing any of those things, they do a few change requests, but not very many, and they take way too long. That would have been quite shocking. It turns out this situation is incredibly common. How many of you get interrupted to do unplanned work? At least half the hands in the room. So, I decided we'd try to do something about this. And to cut a long story short, what we ended up doing, first of all, let's just look at this. How are these guys doing on this measure of predictability, agility, and governance? Well, they had 0% on time because there was a 100% chance of being interrupted to do an estimate. The planning and prioritization was conducted monthly, and the fastest response from a request arriving to being delivered was about 6 weeks. Well, that's not too bad, but it's not great, because a lot of these things were very small. But everything had a business case that was prioritized by return on investment. So on the governance question, they're stellar. Everything's got a business case and only the highest return on investment items are done. But the other two things, they're totally lousy. They've got lousy business agility and they've got no predictability whatsoever. It turns out that senior managers care more about the predictability and the agility than they do about the governance. As long as they're not going to jail, they're not so worried about the governance. It's number 3 on the priority list. So they describe the issues here. That the unplanned work was getting in the way. And this PTC stuff, what were these things? I later discovered PTCs included the tax table updates for the payroll system. Now, if I tell you that, suddenly you think, well, maybe that's a little bit more important than a text change on a web page. You would be right. In the United States, the tax tables are issued by the federal government in the 3rd week of September, and they have to be deployed to production in the 1st or 2nd week of January so that the company can make accurate tax deductions on payroll in the middle of the month. That means they have 3 months and 1 week to get that work delivered. But this department had 0% predictability and an average delivery time of 5.5 months. So if you're the product manager and you just received the change request to deploy next year's tax tables onto the payroll system, what do you do when you show up at the planning meeting? You walk in there and say, these are top priority. And if you do that for long enough, well, it becomes folklore that they're always top priority. And why were they called PTCs? Well, how many of you have a tracking system? You know, some software for tracking your work. Okay, so how many of you have administrator privileges on that system? A few of you. So you'll understand the concept that you have to design a template for the work you're going to track and the states that the work moves through. Well, imagine that a piece of work arrives and it's not a change request, it's a text change. It doesn't require a programmer. So the manager goes to the administrator and says, this work is different, so we need a different template in the tracking system. So they implement that. Then maybe another piece of work comes and it's a banner graphic change. And it's not the same as a text change. Perhaps the manager asks the administrator, can you make a template for this? And the administrator looks at it and says, oh, that's the same workflow. So you know what we'll do? We'll just tell you to use the one that already exists. And everything that uses the same workflow, the administrator says the same thing. Just use the text change template. And after a while, people start to say, why do we call them text changes when they're not text changes? So we reduce the term down to its acronym and everyone forgets what it means. Over a few years, all the staff changed and moved from one department to another, and nobody remembers what these things are or why. So there's lousy risk management. So what we did is we implemented a Kanban system. And this one has a visualization here. The real one didn't. In 2004, all we did is implement this using database triggers on the tracking system. It was completely invisible. But for the purpose of teaching, I'm going to show you the visual version. If we were doing it now, in 2013, this is what we would do. So we have the workflow going from left to right. We have an engineering ready input queue. We have development. We have a test ready buffer in the middle. We have testing. We have user acceptance testing and deployment ready. The deployment was handled by a different department. Then we have a row there for change requests, and we have another row in the bottom here for the PTCs, but it only starts here at the test ready, because PTCs are implemented by the product manager and then only have to be tested by this department. The Kanban system works this way. The Kanban are the numbers at the top of the columns that tell us how many of these tickets, how many work items, change requests are allowed to be in any given column. So we see the test ready column there has a limit of 5, and there's something that's finished development, so we can pull that ticket into the test ready column. Here we can pull something from our engineering ready queue into our development column, because once we've pulled the E ticket, that frees up a space in the development column, allows us to pull in this case, the H ticket. And that means that we have 4 slots free in our engineering ready queue. And we can look at the backlog of requests, and we can pull in 4 more things into the system. The net effect of this is that there is a fixed limit of work in progress in the system. And that makes it a lot more predictable that the workers, they only get to work on one ticket at a time. In this particular example. So we can replenish our input queue from the backlog. In this case, the PTCs are permitted to break the limit because the policy was their top priority. And at least at this stage, I'm not going to argue with that. Later on, we might argue with it, but at this stage, we're not going to argue with it. And we're also marking, in this case, the A ticket as blocked, because whoever was working on that will work on this one instead. So, this is a really important and key point about the Kanban method. Kanban is not a software development methodology. You can't compare it with something like extreme programming. It's as similar to extreme programming as an elephant is to a giraffe. In fact, as an elephant is to a whale. It is not of the same species. There needs to be an existing software development method in order to add a Kanban system to it. Kanban is about scheduling the work and limiting the work in progress. So, I noticed we have a talk on the schedule later, Scrum versus Kanban versus extreme programming. I'm curious to see what's in that talk. This is a sketch, but it's based on the real data. Over 6 quarters, we more than trebled the productivity of this department in terms of change requests delivered. And the delivery time fell from about 140 days down to about 11 or 12. There were a couple of other changes made later. The Kanban system introduction at the beginning made the difference in the first 2 or 3 quarters. So let's try and understand what's going on here. The first thing to realize is that Kanban are virtual. I see a lot of people in the Agile software development community referring to the tickets on the board as the Kanban. That is a fundamental mistake. There's a very well-referenced article on the internet in 2007 that, at least in the United States, has the #1 Google ranking for Kanban, and it is wrong. And the author of that article may be a Gordon Pass Award winner from the Agile Alliance, but it is still wrong. The tickets on the board are not the Kanban. The term Kanban in Japanese refers to signal cards. And the signal cards in a physical situation like a factory are not the work going through the factory. They are additional to the work. They're cards representing a quantity of how many components can be in the factory at any given time. And in this example, the Kanban are the numbers at the top of the columns. Now, some people do implement physical Kanban. They use magnets, for example. They put magnets on the board. And if their limit is 3, they put 3 magnets, and then they place the ticket under the magnet. The magnet is the Kanban. The ticket is not the Kanban. So the Kanban are virtual. They're represented by these numbers. And the board is a visualization of the workflow process. The board is not the Kanban, and technically it shouldn't be called a Kanban board either. It's a Kanban system, and the Kanban system is the sequence of numbers at the top. There is a lot of crap out there on the internet written by people in the Agile community who do not understand this stuff. Be very careful what you're reading. The board is not required, and in 2004 we didn't have a board. We modified the tracking system to use database triggers to implement the Kanban. The database trigger sent an email to the project manager telling us whether there was a slot free to be replenished. Okay, some core ideas in Kanban, and this is probably the most core and fundamental one. Commitment is deferred. Everything that's not on this board is not committed. The act of commitment is when we pull something into the input queue. And technically it's not a queue, it's a buffer, but I don't have time to get into that. When we select something from the backlog, we're essentially saying, we as a business want this thing completed and delivered. The commitment point when we pull it into the system, items in the backlog remain optional. Why is this an advantage? Because the world around you is uncertain and information arrives from the market or from other stakeholders in your business, and priorities change. How many of you suffer from priorities changing? Kanban will help with that. Fundamental concept of deferred commitment. In manufacturing, sometimes they refer to it as postponement. The lean literature uses a term called the last responsible moment. How many of you have heard that? Last responsible moment. Very few. So the last responsible moment would be the last moment in time that you could pull something into the input queue here without it becoming irresponsible. And I'll explain how you understand that in a little while. Once we've put it on the board, once we've pulled it into our Kanban system, we really want to deliver it. We do not want it being discarded after that point. So it's very important that we design the system to have an input queue at a point where we have enough information to know that we really want something, that we're not going to change our mind about it later. And then once we've decided that, we want to get it through there and delivered as fast as possible. Discard rates are very high. Does anybody track this in their own business? The number of things that they put in the plan that don't get done? One hand goes up. So the number was 50%. Okay. We have to click here. Right, so discarding would be rejecting something, right? Whether it's on the board or whether it's only in the backlog. The discard rate at XIT was 48%. Approximately 50% commonly observed. One of our Kanban colleagues, a guy called Dave Nicolette, gave a talk in Paris recently, and he had a quote from the CIO of UPS, the parcel delivery company, and the quotation said, 50% of projects in our IT portfolio are never completed. The discard rate at our portfolio level was 50%. Why does this happen? Why do you think we discard about half the work that we think we're going to do? Because the future is uncertain and new information arrives and we decide that something else is more important. And actually, because the future is uncertain, we need more ideas than we're going to implement. It makes sense to discard stuff. If you're discarding nothing, what does that mean in your world? That your future is absolutely certain. You're absolutely certain you need everything that you came up with. How many of you live in a world where you have absolute certainty of the future? No one. So you will discard ideas. And this, interestingly, this 50% number just keeps coming up again and again, and I didn't set this up. I had no idea he was going to put his hand up and say something. But it doesn't surprise me. Right. Deferring commitment and avoiding interrupting workers for estimates makes sense when the discard rates are high. Because we don't want people being interrupted to, for example, make an estimate of something that you're never going to do. If you're never going to do it, why estimate it? Now you might say, well, we need the estimate to know whether we're going to do it or not. But generally speaking, the cost side of the equation is not that big of a deal in software development. We spend a lot of time managing costs, but actually it doesn't matter that much. Now, the example we had down here was from a bank. Another bank I know of in the United Kingdom spent about £30 million replacing its consumer website. The payoff for that was estimated in the hundreds of millions per year. So the payoff is up here and the cost is down there. The high leverage point in management is to manage for the payoff and not the cost. And the relative cost of one piece of software versus another, one feature versus another, one user story versus another, one project versus another, the relative cost of those is usually very small in terms of difference. We care much more about the payoff than we care about the cost. So we can usually determine whether we're going to discard something based on information we have about the potential payoff. The cost really doesn't come into it that much. Specific delivery commitment may be deferred until later. Now, in this example, I've drawn it saying that we're not going to decide when we're going to deploy this until it's in our deployment ready queue. That's a little extreme. But the point is that just when we pull it into the board here, it doesn't always make sense to make a commitment on the specific delivery date, because you don't know how long it's going to take to move across the board. So why commit early if you don't have to? It's a core idea in real option theory. Do not commit early unless you know why. And if you can't explain to me why you're making a commitment, you shouldn't be making the commitment. Think about your personal relationships. Right? If you can't explain why you're going to make a commitment to someone in a personal relationship, you shouldn't make that commitment. Right? Take that same advice to the office when you make commitments. So Kanban uses a two-phase commit approach. That doesn't mean to say you can't do the one-phase commit, but recognize that it is riskier because you don't know how long things are going to take to move across the board. Next one, replenishment cadence. How often should we refill this input queue? So, the size of this queue will be determined by how often we can have a discussion with business owners about replenishing it. With the XIT, in 2005, they got to the point where they could replenish the queue on demand. When the database trigger sent the email saying there's a slot free in the queue, they forwarded the email to the 4 product managers and said, there's 1 slot free in the queue, what should we start next? Within 2 hours, they replenished that slot in the queue. They didn't hold meetings anymore. They did on-demand replenishment. That's incredibly agile. But most organizations, they can't do that. Maybe they have to meet once a week with the business owners. So the queue needs to be big enough that it will last for a whole week. It's not difficult to determine what that size should be if you understand that. The point here is that the more frequently you can have the discussion about replenishment, the more agile it is. Right, so frequent replenishment is more agile and on-demand replenishment is most agile. Next thing, delivery cadence. How often can we deliver finished stuff to the customer? Someone that will value it, pay for it, or make use of it. And it's the same problem here, like what's the cost of doing a delivery? Maybe the customer doesn't like to take delivery too often because it's inconvenient for them. If you work at a bank, perhaps you have to train thousands of people who work in the branches how to use the new version. You don't want to do that every day. So delivery has its cost. But the cheaper we can make that cost of delivery, the more frequently we can do it. So once again, the more frequently we can deploy, the more agile we are. And on-demand deployment is the most agile. And the technology to do this sort of stuff, the continuous delivery as it's called, that's widely available now, but it's not applicable in every business situation. Defining the lead time. This is the time it takes for something to move from here. The clock starts ticking when we commit on it until it arrives here in the first infinite queue. This infinite queue decouples the Kanban system from whatever's going to happen next. In this case, the user acceptance testing process and then the deployment process. And we're interested to know how long does it take something to move through this system. Because the faster it moves through, the more agile we are. So we've got these three measures of agility. How often can we talk to the business about replenishing the committed work? How long does that work take until it's ready? And how often can we deploy it, deliver it to the customer? And the smaller those numbers are, the more agile we are. The benefit of this is it allows us to defer decision making until later and later. More frequently we can have a conversation about replenishment. The faster we can get it done and the faster we can deliver it, the later we can wait until we actually do something. And that means we could do something else before it. That's better risk management. Okay. This equation here is known as Little's law, that the average delivery rate equals the quantity of work in progress divided by the average lead time. The work in progress is the number of Kanban in the system. The average lead time is how long it takes something to move through. And this diagram here, known as the cumulative flow diagram, visually displays it. The blue area is the backlog, the purple area is the finished, ready to deploy, and in the middle here we have some different states. So here we have the quantity of work in progress. Vertically, the horizontal distance is the mean lead time. And then the slope between those is the mean delivery rate. So visually you can see that this equation is true. This turns out to be very useful if we need to do long-term planning based on how fast can we deliver a large quantity of something. We tend to call those things projects, where the project's made up of smaller things like features or user stories. Alright, improving agility. I've talked about this already. The factors affecting the agility are how often can we hold the replenishment conversation, make the deliveries, and how long do things take. Kanban allows you to decouple those three things. That's a core difference with a lot of agile software development and project management methods. They couple those three things together. Now that's convenient because it makes your version control system easier to manage. It makes your configuration management problem easier. But it's not that convenient for your business. If you're in the media industry, for example, real-world events do not unfold in nice sort of 2-week time boxes. The media industry is a massive adopter of Kanban. One of the biggest, earliest examples was at the BBC. They have something like 25 to 30 different departments using Kanban over the last 5 years. One of them produced an academic case study that's published in the IEEE Management Journal, and it demonstrates that that particular team generated something like £700,000 of additional advertising revenue through faster delivery of the web pages that they developed, where they actually track the incremental revenue from the earlier delivery. That was the first team in the BBC, and it spread virally. There are very big Kanban implementations at El Globo, which is South America's largest newspaper based in Sao Paulo in Brazil. We know of other ones at companies like Comcast, that's a cable TV company in the United States, Time Warner, Time Life, The Lonely Planet. There's a published case study from the Lonely Planet TV channel. IPC Media, which is a magazine publishing company in London, and so on. This says the benefits of limiting width. The benefits of having a Kanban system aren't just about the replenishment, predictability, the lead time. There are just some core benefits from limiting the quantity of work in progress. Marking things as blocked. So this one is blocked because it needs a specialist test environment and that's not available today. So what's your manager doing about it while you're sitting with nothing to do? Now, on the other hand, if you'd started something else, your manager probably isn't bothering to do anything about it. Organisationally, nobody really cares because, hey, what the heck, they're still busy. But somebody cares about this ticket or it wouldn't be in the system. Right? Some business owner actually cares about how long that thing takes to get delivered. And when you focus on things that are blocked, organisationally, you develop a capability to get things unblocked. And the better you get good at that, the faster things move across the board. The next one here is this is blocked because we found a defect in it. It failed a test. It turns out that the less work you have in progress, the less defects you insert in the code. How many developers here? Keep your hand up if you don't believe me. When you're focused on just one or two things at a time, you make a better job of it, right? Less likely to have bugs. Oh, and there's another correlation. When things take a long time to move across the board because they were blocked, turns out you put more bugs in it. Now, academic software engineers were not studying this problem because they assumed that when you're not working on it, you can't be inserting a defect. So they didn't bother to track that. You go study academic papers out of places like USC, Carnegie Mellon, UC Berkeley, and so on and so on. Nobody bothered to track the waiting time because the assumption was you can't put a defect in the code when you're not working on it. But let's imagine it spent 6 weeks blocked. What happens in the first 10 minutes when you start working on it again? Your memory of it's not that good. The likelihood of inserting defects goes up in a non-linear fashion the longer things take to move across the board. So reducing the lead time through the system reduces the defect rate, and reduced defect rates makes the whole thing more predictable. This is a distribution graph of lead time for change requests and bugs going through a system, a department that I managed in 2007. This is for 1 month. And you can see that there's a cluster of items that took a few days only. The x-axis has the number of days, and the y-axis has the quantity of items. And we can plot on this things like the mean, in this case 31 days, and the 85th and the 98th percentiles, which are 44 and somewhere between 100 and 160, and I made a guess at 105. And this is useful information. If someone said to you, how long on average does it take you to do a ticket, to do a change request? And you could say, well, 31 days last month. But if you want a guarantee that we'll have it done, how about 105 days? Now this is real data from a real team. Other people have published similar data. Rally software. Many of you have heard of them. Rally makes software for tracking Agile projects. They publish their own data from their own development teams. Typically, the high end, the tail on this distribution, is 5 times the average. And in one team that they published, the average was about 2 weeks, and the tail on the distribution was over 100 days. So if someone said, when will it be done by? You'd have to tell them about 100 days. But on average, things only take 2 weeks. That makes you look pretty stupid. So how might we counteract that? Well, how about we did an estimate? When you're doing the estimate, you're focused on how much time you're going to work on it. Out of this lead time, how much time do you think is actually work versus waiting? We're going to come to that in a minute, which explains why estimation is a low-value activity. Also notice, this data is multimodal. That means it has two bumps in it. If we separated out the data, so that it's not multimodal, but we have two graphs that are single modes, two distributions with single modes, what we actually see here is that the production defects, the bug fixes, they only take 5 days on average, and 25 days is a slow one. On the other hand here, the change requests, they take 50 days on average, and we have this 150 days is a slow one. This is really useful information, because now someone comes and says, how long will it take to fix the bug? And you can say, well, on average they take 1 week, but if it's a bad one, it might take 5 weeks. Where prior to that, you are going to respond and say, well, it's 6 weeks on average. And this makes you look more professional, and you've got greater accuracy. So what if we made 2 lanes on the board, one for change requests and one for bug fixes, and we set limits on those lanes? So now we've got Kanban limits on the columns and corresponding limits on the lanes. That means we have a fixed amount of change requests and a fixed amount of defects in our system at any given time. And if we do that, that should allow us to have fairly consistent distributions for how long these things take. This demonstrates what's called flow efficiency. Flow efficiency is measuring of the amount of time something took, how long did it spend waiting? So it gives us this equation, work time divided by lead time times 100%. Anyone like to guess what typical data is? Maybe I pick on my friend who came up with 50% for this grade. What do you think a typical flow efficiency is for your average software organization? This lady in the middle is laughing. What do you think? So, again, consultants that I work with, Kanban consultants around the world, they measure this data. When they go into clients, they collect this sort of data and they report it. And they come to conferences and they report it. Well, recently, Zolf Babok from Budapest reported the team he managed until very recently had an initial flow efficiency of 2%. So if something took 100 days to complete, they worked on it for 2 days. 98 days were spent waiting. Håkan Fors, who is a consultant from Stockholm, he's recorded this data with quite a lot of clients, and he reports that no client he's encountered had a flow efficiency greater than 5% when he first met them. My personal experience is 5 to 15%. And the XIT guys in 2004, they were 8%. So the interesting thing is, if you're a developer and someone says, hey, can you do an estimate for this user story? What you're thinking about is, how long will it take me to do this? And that might be 1% of the delivery time. But remember the equation, delivery rate equals width divided by the lead time through the system. So if you're estimating something that represents only 5% of that total, you're not estimating the waiting time. And the estimation is therefore useless information because it doesn't tell you how fast you're going to go. Now, if you happen to be working on one of the benefits of reducing lead time. I actually talked about this. The bug rates go down dramatically when you reduce the lead time. And this just shows some more results from XIP. The flow efficiency went from, what is that, about 8% to over 90%. And the usage performance, so how much of the work they promised was delivered on time, went from 0 to 98%. And that happened very quickly once the Kanban system was installed. Yeah, there are the numbers. I'm going to skip this one. I want to talk about better governance. So, if you're providing the money to pay all of you guys, there are two problems you need to worry about. One is, do I have smart people thinking of the right kind of work to be doing? Because there's no point in paying all you developers to build the wrong kind of stuff. It'd be good if you were thinking of the right kind of stuff. And then the other fact is, more ideas we're going to implement, then the other half of the problem is what things you doing. And if you're a developer and right now today you just finished something and now you're idle, what should you start next? Now if I was the owner of your company, the one who put up all the money to create it, if I could trust that every time you were idle, you picked the very best possible thing you could work on next. And the other half of the problem, I trusted that we had really smart people that came up with really good ideas of what we should be working on. If I trusted those two things, my investment is safe. Those are the two things I really care about. Governance is not a hard problem. The question is, how can I have that level of trust? Well, today we're only going to talk about the second half of the problem, which is, what should we put in the system? And here we have this red-coloured worker, and he's idle right now. And the question he's got is, there's 4 things that I can start, which one should I pick? Which is the best choice? Well, if he had enough good information, he would be able to make an appropriate decision. And in this case, there are red ticket items which require the specialization that he's good at. So with a red ticket item available and he's a red coloured worker, he says, oh, I'll take the red ticket thing because I'm good at those. What if there was no red tickets available? Well, now he's either doing something he's not good at, which could be risky, or he's idle. And if I own the company, I'm not happy about that. I kind of like him to be doing something useful. That's really what this says. So, the psychology of what I've presented here is a probabilistic approach. This could be difficult for some people to get their head around. How long will it take to get this thing done? Well, you know, on average 50 days, 85% that's 6 out of 7, 60 days. But if you're unlucky, it's 1 in 7, maybe 150 days. And you're the customer and you're saying, you know, I don't want to take the risk. What if I'm 1 in 7? Alright, what if I'm going to be 1 in 7 and you guys are going to take 160 days? That's not acceptable. Well, the way we counter that is to introduce different classes of service based on how risky something is. That's another way of saying how valuable is it. Because it turns out value is just one dimension of risk that we have to manage. And I introduced a method for assessing the value of something based on its cost of delay. Now that's the flip side of that is the opportunity of the market payoff from whatever we're going to build. And if you ask marketing people to answer a question like, if we deploy this in March, how much will it be worth by the end of July? If they give you an answer to that question, they are lying. Because they don't know. They could speculate, but they don't know the real answer. And if you said, here are 5 different ones, tell me how much they'll all be worth if we deploy in March by the end of July. The possible range of values for those is so big that you can stack rank them any way you like. If they give you an answer to the question, how much is this worth, they are lying. Unless you know for a fact that when you deploy this feature, you're going to fire people, because then you save the money that you were paying those people. That's a calculable cost, right? But if it's something that your customer might pay for, you don't know how many customers or what they'll pay for it or when they're going to make the purchasing decision. But it turns out, if you ask the marketing person, could you sketch approximately what the market payoff function would look like? They can do that drawing, because you're not asking them to put any values on it. So we introduced this system of using these approximate sketches that have, on the y-axis, the impact. It's another word for value or risk. And on the x-axis, time. And you see the different shapes here. And we've classified them into 4 categories. Expedite, fixed delivery date, standard, and intangible. And it turns out this set of 4 has been incredibly robust. And it's worked in all sorts of industries all over the world for most of the last 5 or 6 years with hardly any modification. And if we know the shape of the cost of delay, we can classify something into how urgent it is. And once we know how urgent something is, at least approximately, we can design that into our Kanban system. So here we have a Kanban system. Now it has 4 lanes on it. One for expedite requests, very urgent, limit of only 1 at a time. 2 fixed delivery date items. Fixed delivery date means something that's out of your control. allocate capacity in the system across these different types, we're effectively hedging the delivery risk. What happens? And that might give us distribution curves for delivery that look a little like this for the different classes. It tells us how urgent something is, and it gives us clues about how to prioritise it. In other words, what should I pull next? If you had a choice of a fixed delivery date item or a standard item, well, you might think, well, obviously, I would explain to you why deferring decisions is useful and important. This is the cost of the lead product feature for the summer holidays. And right now we don't need that, but we like it launched in the spring. So that's when we need it. That's when our opportunity curve starts to rise. Well, if we know the distribution for our standard class items, we can map that against this. So here's the 85th percentile on that distribution, and we can back out in the calendar back to here, and that tells us when we should start it if we want a 6 out of 7 chance of delivering it. Now, some people might call this an estimate, but it took us about 5 seconds to do it. And it's based on real facts. It's not based on rubbing a crystal ball and speculating about how long something might take. Now, of course, we could defer commitment until later, but what does that do? It increases the risk that we're carrying. Or if we don't want to take the 6 out of 7 chance risk, we could move this graph this way and start it earlier. What would we do if we started it here where I suggest, but then it's not going fast enough? What option do we have? Change its class of service. If you really want it, when you say you need it, you can change its class of service if it's not going fast enough and speed it up. This is known as the optimal exercise point in real option theory. It is the mathematical definition for the last responsible moment that appears in the lean literature. We talked about this. Cost of delay attaches to the deliverable. What if we were trying to deliver something that took a long time, like this 2,200 feature project? Well, it turns out that when you start projects, you go slow, and then you speed up for a while, and towards the end, you go slow again. Well, if you know that, then you can simulate it. And I use this very simple thing of 20% of the time we're going to go slow, 60% we're going to go fast, and 20% at the end will go slow again. And if we know how many requirements are in our project, they go on the y-axis, and then we ask the question, when do we need this by? Which is a cost of delay related question. And then you reverse engineer how fast you need to go. Remember the Little's law equation, delivery rate equals WIP divided by lead time. The lead time is from observed capability. This is the magic here. it turns out that because most of that lead time is waiting, there's very little human influence on it. You can bring in the world's best extreme programmer, and he could go 10 times faster than the average guys in the department. That will make about 3% difference in the delivery time. It turns out that the hero developer that can do 10 times more work than the guy sitting next to him doesn't make that much of a difference. Sorry, but no. I used to have a big ego as a developer too, once upon a time. I used to think I made a big difference. But it turns out not so much. At least not in big companies. So, this is environmental. These distribution curves don't change much unless you're actively trying to change them. The delivery rate, we just got that from our plan. So that tells us how much WIP we're going to need. And that will tell us how many people we're going to need. If we put some real numbers on that, the graph I showed you requires us to go at 55 features per week over a 2-year period of time. And if we know historically that an average feature takes 2 days to move through our system, then that's 0.4 weeks, and that tells us the WIP should be 22. Well, let's just go back. A little bit of experience, and I rounded board that looks like this. There are actually 2 boards here. The green tickets are large things that the customer calls requirements, and the yellow tickets are small things that we call user stories. There were on average 22 yellow tickets for every green one. So the green tickets are the parents of the yellow children. And we have a board that's got an input queue and analysis, and green ticket in progress, integration testing. And then we have another board in the middle that has 5 lanes for 5 green tickets. And then it has the yellow tickets flowing through that says proposed, and then design, coding, resolve, keys, testing, and then done. So what we're interested in here is we need these yellow tickets to move across here on average in 2 days. And if we can make that happen, we will deliver this massive 2-year project on time. And this one was $11 million US, 55 people. The 3 columns in question are here. The design, coding and testing. We need those yellow tickets from the point we pull one from here into here. We need every other one being delivered across here in 2 days or less. That's the key risk to manage this. $11 million project, 55 people. I'm the senior director. I'm not even directly managing it. The manager who was managing it, what he's worried about is, are the yellow tickets moving across on average in 2 days or less? What an incredibly powerful thing. Everyone on the shop floor, all the developers, all the analysts, all the testers, they all knew that if we're going to deliver this project on time, these yellow tickets need to move across here in 2 days or less. That's the only question I need to answer. If we can hit that number, we deliver this project on time. The Kanban system takes care of the rest. Now, you'll notice, if you listen carefully, I used the median and not the mean. Turns out human beings don't do mean very well. But median's a lot easier. Median's the concept that every other ticket takes 2 days or less, and the odd ones take more than 2 days. Now, from the distribution, the median is a little smaller than the mean. So if we use the median as 2 days, there's a little bit of a risk there. But I hedged that by increasing the 22 to 25. And the difference might be 2 days versus 2.25 days. So maybe it's not that huge. But just be aware that the median is easier for humans, but it's not the number that's in the equation. So, some conclusions. Kanban systems defer commitment is the core idea. And if you suffer from a lot of priorities changing because new information arrives, deferred commitment will help you. And deferred commitment, coupled with things like eliminating estimation and replacing it with a probabilistic understanding of what's really happening, those things will improve your predictability. Not just a little bit, but dramatically. Committing early is politically expedient. If you work in a big company, you understand this. The customer likes to hear, IT's working on it. They like to tell their colleagues, don't worry, I spoke to IT and they told me they're working on it. That makes them feel warm and comfortable. The flip side of that equation is that you let them down because you don't deliver it when you promised it. Because you have too much work in progress and too many other interruptions, too many priorities changing. So, you have to counter that loss of comfort with more trust. And the visibility that's in the system and the data you can produce, that can counteract the discomfort feeling. The discomfort of what's in the backlog, it might not get chosen. Maybe you explain that, 50% of everything you guys suggest doesn't get chosen. And that makes sense because the future's uncertain and we need to have options. And then you can start to get people comfortable with the idea that you don't need to commit so early. This just summarizes this core agility concept. The more often you can replenish, the shorter the lead time, and the more often you can deliver, the more agile you are. Alright, the better the agility in the business. Why? Because it allows you to defer commitment until later. And deferred commitment until later gives you more options. And options is how you respond to an uncertain future. Which is why the media industry loves Kanban. The last thing here says, the visualization of real business risks on the board and hedging with capacity allocation gives people the confidence that you're actually managing business risks that matters to them. And the fact that you use real data and you analyze it probabilistically means that you're dealing in facts and you're not crystal ball gazing and speculating about the future. I didn't mention it, but some people report, some Kanban consultants report from their clients the correlation of estimate versus lead time. So estimates, for example, in number of story points. Now remember the distribution sort of looks like this, and you would think that the 1 and 2 story point stories are at this end of the distribution and the 13s and the bigger ones are at this end of the distribution. No correlation. Real world data on estimates versus lead times does not correlate. What this tells us is it doesn't matter what the estimate is. It matters how long the thing spends waiting. So, more predictability, better business agility, and better governance, and very simply done by limiting the work in progress and visualizing the real business risks. Use a Little's law equation, math distributions of lead times, and a general philosophical summary. Study what really happens in your universe. and don't speculate about the future. No rubbing the crystal ball, no pretending, no kidding yourself on. Look at what really happens in your universe and study that data, use it, and probabilistically predict the future. I'm probably way over time, but thank you for your attention. If we have time, yeah. There's two hands up, but we'll try and do it.
Engineering, right? I think it's important milestone. And also it's not because they enable these specifications, right? The requirements process is very important, right?
It needs to get definition of brain.
Okay, but if it's not actually enough, or if it's not a variable projection that rest is not
well, you can't do it in the system if it's not ready.
I just want to ask you, there's something about Scrum that you have not told me. Say that Scrum, then backup planning, that is sprint level, can be implemented as Kanban.
You could do it, and if that's what you're currently doing, that's where I would start. But I think if you stop doing it, you're going to quite it.
So, you're saying that
No, I'm not saying that. I'm saying that if you add the Kanban system to your existing Scrum implementation, the behaviors you currently have will probably go away when you realize that they're not adding value for you. But I'm not suggesting that you stop right away.
Thank you for a nice presentation. Very good. Yeah. I may not advise Agile.